Alright, so we're given an array, and each index in the array represents the price of a stock on a given day I. So basically what it means is that on day 0, the stock costs $7 to purchase. On day 1, costs $1 to purchase. On day 3, costs $3 to purchase, and so on. And we're told to that we're only permitted to complete at most one transaction, design an algorithm to find the maximum profit. Okay. And it also says you cannot sell a stock before you buy one, just in case you thought you could. So something you might think of at first is to have two for loops, one outer for loop and then one inner for loop to go through every single possible combination of buying and selling. So maybe this arrow at 7 represents we buy 7, then this inner arrow represents selling at $1, selling at $3, selling at $5, and then just going through like that for every single possible combination. That would work, but it would be a O of n squared solution, so not the best. And there's actually a way we can do this in O of n. And so what we're going to do is we're going to keep track of two things. The first thing we're going to keep track of is the minimum price. And the second thing we're going to keep track of is max profit. And we're just going to have these be two ints. And so when we start, what we're going to do is initialize min price to be the max integer value. I'll just write infinity. And when we start, we're going to initialize max profit to be 0. So what we're going to do is we're going to iterate over the entire array using one for loop, and at each index we're going to say is prices of I, is the current price less than the minimum price, and if it is, we'll update min price. And otherwise, if prices minus min price, which would be our profit, if that's greater than max profit, we're going to make max profit equal to prices of I minus min price. So let's walk through this and see how it would go. So here at 7, we're going to update our min to be 7, and max profit and then we'll continue. 7, we go to 1, and now, so prices of I is less than min price, so we're going to update it. And now we're going to go to 3, and so now prices of I is not less than min price, so we're going to go ahead and check is prices of I minus min price, the profit, is that greater than our max profit. So 3 minus 1 is 2, so at this point the most we can make is $2, and we're going to keep doing that. Same thing for 5, so we'll have 4 here, because 5 minus 1 is 4. Continue to 3. This time we don't update anything because the max profit is not updated. Now we'll get to 6. 6 minus 1 is 5. And we get to 4. And we don't update anything because 4 is less than 6. So now we just return our max profit, which is 5. And if we check the LeetCode expected results, that is the expected output. So now let's code it. Alright, so just like in the written solution, the first thing we're going to do is make two variables. We're going to say int min is equal to, and then we can't say positive infinity, or we can, but I don't think it's an integer. We're going to say int max value. And then also we're going to say int max profit is equal to 0. And then we're going to iterate over the array, just like we did when we were writing it out. And so we're going to say for int I 0, prices.length, I++. And now we need to check, is prices of I less than min? And if it is, we need to update our min. So we can just say min is equal to prices of I. And else, what we need to do, well, first we need to check is prices of I minus min. Is that, so is our, well, first we need to check is the max profit that we can make at this point different than our previous max profit? And at this point, our max profit is prices of I minus min. Is that greater than max profit? If it is, then just update max profit. And that should do it for our for loop, and we can go ahead and return max profit. All right, let's run it, make sure it compiles. So we passed that test case, check all of them, and it works. So now let's talk about the time and space complexity of this. So as far as time, we have one loop, and it's going from the entire length of prices. So that's going to be O of n. And because we're doing only constant work inside our for loop, it's the program as a whole is going to be O of n. And now as for space complexity, we're making a couple variables, but we're not really making any miscellaneous data structures or anything like that. So our space complexity is going to be constant, or O of 1. All right, and so that's going to do it for the best time to buy and sell a stock. This problem is actually on the blind 75 list of LeetCode problems. So if you're currently trying to interview, I would recommend you check out that list. If you enjoyed this video, drop a like. If you learned anything, you could subscribe. And as always, have a nice day.